Hello YouTubers! From my last video about repairing the old tube radio, I got some questions about how we can measure and check this couple capacitor, which is really directly connected to the gate of the final tube, and on the other side there is mains for the pre-final. So having a look back into such a schematic, we can see the following. Here we have our supply voltage, which is well, 220 or 230 or even higher. So in this case, I don't know whether you can read it, but it is 260 volt DC. And this here is a final tube of the audio amplifier, and here this is the little coupling capacitor. What we can see here is that from here we are feeding the output transformer to convert the resistor for the loudspeaker, and a little bypass is going through here and is directly feeding the pre-final. What does that mean for our circuit? So, yeah, the 230 volt DC or whatever is passing by this little couple capacitor, and if we look much more in detail, we can see here this little two dots. And what does that mean? So here is information on that, and two dots means that it must resist 500 volt of DC, which is quite high. So since a capacitor is a DC blocker, so no DC can flow through, the high voltage which supplies the anode of the pre-final can't directly influence the gate of the final tube. The final tube, the gate of the final tube, needs a negative voltage to be at the right bias point. And you might imagine that if this capacity is leaking, then the positive DC voltage can directly pass through the gate, and we may have I don't know, 5 or 10 or 20 volt DC, depending on how much leakage current we have flying through this non-polarized capacitor. So you might imagine if we have maybe let's say 10 volt DC at the gate of the final tube, then the Beer's point is completely wrong, and so the complete current can flow from the anode to the cathode, and that means this tube doesn't work, and it might even destroy the tube, even if tubes are not that sensitive like transistors. So they would be blown up directly if they get such a high voltage, and open up completely the track from transistor from collector to emitter. So that is definitely wrong, and so that is something where your circuitry doesn't work at all. So what you really need is a good capacity, which is really blocking the DC, that only the audio frequency can pass through, because we know for audio frequency a capacity is a resistor depending on the frequency, but in any case radio frequency, audio frequency can pass through, and DC gets blocked. Okay, with this knowledge, I have here a little circuitry out of a tube radio, and what you can see here, this is a typical capacity, non-polarized, which is could be used as coupling C, but this one was in the somewhere else in the audio stage, whatever, but it is the same procedure. And so, well, how can we check if this capacitor is working or is good, and no DC current can flow through, so no leakage is what we are looking for? Well, you might think, okay, I have a capacity tester, and with a capacity tester it should be possible to check it. So what can we read here on the capacitor? 0.1 microfarad, so that is 100 nanofarad, and this capacitor is good for 250 volt DC. Okay, that means I adjust here my setting to 200 nanofarad, because we expect a reading of 100, and yeah, let's connect the alligator clip. Sorry, it's a bit difficult here through the lens, sorry for that. So I have now connected the alligator to the capacitor directly, and the reading is nanofarad, 178.93. So that is a bit funny, but you may think, yeah, the capacity is very close to 200, and we expect a reading of 100, So yeah, capacity is already available, so that might be okay, even if it is jumping. But maybe my capacity tester might be faulty, so let's bring another tester into the game, and therefore I have this model. This is a PIC operated capacity tester, and now we connect the alligators directly to the capacitor, which is again a bit fiddling. So, and what can we see here? 30 nanofarad, and it is increasing. So increasing, that means the capacitor gets loaded up, so that could be normal, and we see still increasing value, and yeah, 50 nano and 60, and so that is a bit different reading, and it is jumping, but yeah, okay, now we are reaching 70, and yeah, okay, could be okay, because the capacitor is charging up, so that is what capacitors are doing, but this little value shouldn't take that long, so I'm not convinced. I mean, okay, we are reaching now the 100 nanofarad, so you could conclude it is okay. But I'm not really convinced. So yeah, I will take it away, and let's bring in my multimeter, and modern multimeters have a capacitor measuring capability on board. So okay, let's connect my jacks to the meter, and let's see what is happening. No reading at all, and suddenly it's telling me overload. So what does that mean? Now I have 3 different capacity meters, and well, you might be thinking, yeah, you have seen more than 100, you have seen increasing value up to 100, and well, maybe something is wrong, even it is a high-end echelon multimeter, but yeah, so what can I conclude? I tell you what, finally you can't really probe a capacity, a non-polarized capacitor like this. So what you really need to check a capacitor like this is a high voltage ohm meter. So what do we know from capacitors? They should be they should have a high resistor for DC. So that means they should block DC, and therefore yeah, we bring this little device into the game. So this is an isolation tester. This model is called ISO-test. And what does it do? So I can adjust my DC voltage from 20 volt DC up to 500 volt DC. And then I connect the leads to the capacitor and start measuring. And what I want to see is, in best case, that we don't have any movement of the needle, because that means that the resistor is infinity. Yeah, so that is mentioned here. And if the needle is moving, so you can see 20 mega ohm, 10 mega ohm, 6420 mega ohm. So that is a mega ohm meter for high voltages. So that is a very, very handy device. And if we now connect the leads to our capacity, so now it is connected, and my isolation tester is adjusted. You may see the white line here, so that is the indication where it is put, where I have put it on the scale, and it is now adjusted to 200 volt DC. And now I press the test button, and yeah, we can see both. And you should watch the needle for movement. Now I press. Oops. Oops. So what is that? What is that? The capacity shows a resistor smaller than 1 mega ohm. So that is, I do not want to say it is a short, but you know, that is what you don't want to see. Okay, maybe I do something wrong. Okay, so let's take it away and bring two modern capacities into the game. So you see that is a Weimar, again, or as well, 100 nanofarad with a capability of 630 volt DC. And this is another model, looks a bit retro fit or whatever, and that is 100 nanofarad as well, and again with capability of 630 volt. Okay, so if it is right what I have what I'm telling you, I should read a complete different value, a complete different resistor on my meter. So okay, now it is adjusted. Now it is the alligators are connected to the capacitor. I'm still on 200 volt DC, and now I do the test again, and please watch the needle. Whoops! Hey! So what is that? So you have recognized, I'm still pressing, so it is measurement is still in progress. So on the first push, you recognize that the resistor is low, and then it is increasing. So that what you can see is the charging of the capacity. So that is absolutely normal. And then the needle is moving to the infinity mark, but it is definitely beyond 200 mega ohm. So once again, yeah, so that is the charging, and after a short while we see exactly what we expect from capacity. So this capacity is completely blocking the DC. So from that perspective we can say, great. But what happens if I move my DC voltage up to, yeah, let's say up to 500 volt? Because this capacity is able to take 630 volt, as you can read on the front. Okay, so same test with 500 volt DC, and what can you see? Yeah, we can see again the charging of the capacity. So that is absolutely right, and that is what we expect. And then needle is going up to infinity. So yeah, we can be sure that there is no leakage current at all, and that is what we expect. Okay, so now be careful, because this capacity is charged up with 500 volt, and we have definitely 500 volt. When we go and discharge it, I don't know whether it was you was able to see it, but there was a little spark, and now the charge is gone. So yeah, if you work with isolation tester, you should always have in mind that if it is charged up with 500 volt, the 500 volt is loaded into this capacity. So be careful. This could be dangerous for your life, even if or especially if the capacity is much higher than 100 nanofarad. But that could become critical to your health. So be careful, be really careful. Okay, let us check the same with this axial capacitor, and yeah, we connect it as well to the isolation tester, and as we know from the information here, it is also good for 630 volt, so I can leave it on 500 volt, and I push the button, and same behavior, it moves back after charging to infinity, and that means great. So there is no current flowing, and it is completely blocking the DC voltage. Same problem here. Need to discharge it. Tack! Little spark, and now it is discharged. Okay, back to our initial test. Let's go back to 250 volt, because this is only able to take 250 volt, and let's check it again. 250 volt, and let's press the button, and what we see is that is nearly a short, and that is obviously the reason why all my meters was not able to read the capacity. So, okay, let's take the new one again, and let's connect, and let's connect, yeah, and let's connect the capacity, the modern type, which should have 100 nanofarad as well. And now you can see the reading of the capacity tester, and you see exactly what we expect. So the reading from the faulty one was an indication that something was wrong, but we didn't get a right information. And okay, but let us prove that this measurement is okay. So let's again take the Agilent multimeter, and let us connect the capacitor to the Agilent, and yeah, what we can see here, again, 100 nanofarad. So I think that is a proof that this capacity has the right value, 100 nanofarad, and it completely blocks the DC. So that is a good coupling capacitor. And back to this guy. Yeah, now I will press it again to make it visible again. You see, that is a short. So that is not even 1 mega ohm or 500 kilo ohm. So that means if such a capacitor is your coupling capacitor in your circuit, which is this, you have the complete supply voltage, which is for the pre-final, is complete connected to your gate, and that is totally wrong, and may destroy your tube or your transistor, or what have we. So that is the only test where you can finally be sure that your capacity is good or bad. I mean, this one is a really worse example. Normally a bad capacity often shows minimum 10 mega ohm or 6 mega ohm. But anyway, if the gate resistor is let's say 1 mega ohm, and you have 100 and you have 10 mega ohm coupling capacity resistance, then it is always a tenth of your supply voltage. Let's say a supply voltage, let's say, is 200 volt or 100 volt. Let's say 100 volt. Then it is still 10 volt DC at the gate resistor, which is then feeding the gate with 10 volt, and that is what you don't want. If you remember that we need a negative bias voltage for adjusting your gate in idle mode. Okay, I hope this little video was interesting and a bit helpful to understand how it works. And if you like it, thumbs up. Thank you. Bye.